Hi, this is DC here. Welcome to the second video on SRI512 NFC tags. In the last video, we just touched the overview of SRI512 tags. And from this video onwards, you're going to see how to use and how to understand what these tags are capable of doing. So you can see here, I have connected my the discovery board based on CR95HF. And this board is also manufactured by STM. And before I would start, I thought a bit of a theory about how the readers and the tags works, especially in case of SRI 512 or 516. I think it's 512. Sorry, I apologize. It's a 512 tags. Now, what you see here is 4 NFC tags, and these tags are SRI 512 tags, and this doesn't have to be SRI. This can be any SRI tags. This can be SRIX 4K or the other tags. We have a reader writer, and this reader writer must be capable of reading and writing to the type B tags, which I mentioned in my previous video. Now, against each of these tags, so I have written C1, C2, C3, C4. These are called as the chip IDs. So these SRI tags are capable of producing a random chip ID every time you bring them into the electromagnetic field. The first step, or the first thing the reader does, is create an inventory of all the chip IDs present in the field. So I have got 4 tags here. So the reader creates inventory of 4 tags, C1, C2, C3 and C4. Most often these C1, C2, C3, they are all 8-bit random number. And in the second step, what reader does is it selects a tag at a time, does the operation and deselects it. As I mentioned here, select C1, do the read and write and all kinds of operations with C1, then deselect it. In other words, you can also deactivate it. So here the reader is trying to process the tag sequentially, one after another. So once the tag 1 is finished using, the reader can do the same thing for the tag with the chip ID C2. So select C2, read and write using this C2 tag and deselect it. So likewise select C3, read and write to C3 and deselect it. Now this is the overall steps taken by most reader writers using this SRI tags. So when you have this board connected, you have to run this software called CR95HF development software. You can download this software from the STM website, and I have purchased a pack of 4 SRI512 tags. Now it's very difficult to find these tags from internet. The only place where you can buy most of the time is the Alibaba.com or AliExpress, but the problem there is you have to buy in hundreds or thousands. I somehow found one seller in eBay who sells this in a pack of 4. I'm going to put that seller's eBay address in the notes section of YouTube. Please you can use that and you can buy that before the stocks finished. And these tags, these are sticker tags. They are pretty small as well. You can see the antennas, and looks like these tags have got a print of antennas there. Okay, now I have made a paper bridge, so I'm going to place this tag. This is a brand new tag, and let's see what the software can do. Now I'm going to choose my board CR95HF, And if you go to IS4, we know this is a type B tags. Choose here. Now you can see the tag is mentioned here, SRI512. You also have SRT512 and SRI2K and other one. I'm going to use SRI512 because we know that's the tag. So as I mentioned before in this the sketch on how the readers and the tag works. So the first thing is we have to get the inventory. Now I'm going to do this, maybe the easiest way is if you just click this anti-collision button. So you can see that this process has detected a tag with chip ID 66B. Now the first thing you have to do before you can read and write, you have to first select the tag by hitting this select chip ID button. So we are sending the select command of this SRI512 tags, and it is selected because I'm going to go through this this command in the later videos, and we have selected it. I'm going to read. So I'm going to read here. Now you can read the single block, and you have to mention the address from and to. We know this tag has got 16 blocks and each block is 4 bytes. You just hit this read signal single. Now because this is a new tag, the initial memory content is all Fs. So the initial value is all bit 1. So this is how you read all the blocks. So you can also try this. Let me see if you can clear. Okay, you cannot clear. Now, and also if you hit this button get UID, this is going to send a get UID command and get the UID of the tag, which is a 64-bit. In case of the type B or ISO 1443B tags, the very first byte indicate this is of type B, followed by the manufacturer tag 02, followed by the remaining serial number. So you can probably, let's try to read just one block. So I'm going to enter this from and to a 00 read block. So got one block. If you hit this button read system area, we have seen in the previous video, every tag has got a system block at address 255, and if you hit that, this is what you see. It has a data of FF and 7F and FF. Okay, I'm going to now go through this data in detail in later videos. Now I'm going to do, we know how to read now, so I'm going to write something. So first I'm going to read the block 0. I'm going to write. So you can either fill the value, or I can write values like say 41, 42, 43, 44, and write single block, right? So you got the error code. I'm not very sure whether this error code, or let me try to read. You can see here, the data is indeed is written. But remember in the very first video we saw in the data sheet, the write command does not return any response. It is probably because of that reason, so okay, we were seeing the error code. So in order to know the write is successful or not, you have to read after the write operation. Now I know that we just wrote 41, 42, 43, 44. It's read back. The best thing is I'm going to take this out and try to clear that. Anti-collision. Now look at that, this time we got a completely different random chip ID. Now this has got a random generator, this tag. So I'm going to select, it's selected. Then I'm going to read all the 16 tags. You can see the first block is what we have just written, and once you you finish this tag operation, we can choose a completion. Now if you try to read now, we get an error message. So because once we say the tag is completed, you have to go back again and repeat this select process again. So now I'm going to show you in a different way of writing. So we're going to follow a little bit of from the documentation as well. So now I'm going to show you how to do read and write operation, but using a different method. I'm going to follow this transition diagram that is mentioned in the documentation. Now all tags, when they are not in the field of the reader writer, they are in the power off state. When they enter the reader writer field, they get into ready state. Now I'm going to place this tag, and according to documentation, this tag must be in the ready state. Sometimes you might get an error message because the reader cannot recognize the tag. So I would advise you to keep changing the position. Try and find the best position for your tag. Now we have the tag in the ready state. So you go back to the software, and before we do the read and write operation, the tag must be in the selected state. So the only way to reach here is from ready you have to come to inventory, and from inventory you have to take this path by using the select chip ID command. Now we are in the ready state. I'm going to send the initiate command, and if you look in the documentation, the initiate command will move the tag from ready to inventory state, and it also returns a new random chip ID. So let's try that. Now I'm going to click on initiate. Now this software has sent the initiate command, and it has also extracted the chip ID from the response. So the chip ID here is 62, and if you look at the response here, this is the entire response. This response carries so many things before and after. The documentation says the initiate command returns 1 byte followed by the 2 byte CRC. Now 62 here matches this. If you keep the documentation doesn't stop you from using initiate command while in the inventory, so I can keep on using these commands, initiate or pcall. We're going to come back to pcall later. Initiate command. So I'm going to try initiate few more times. Initiate, you got a new random ID 73. If you look at here, the 73 is here. Okay. Initiate, so you got just 73. Okay, so you didn't get any new random IDs here. Next thing is you have to select. Now the select command has made the transition from inventory to the selected command. So because the tag is in selected state, we can use all these commands. You can select again, or you can read block or write block or get UID. So try this get UID. We got the UID of the tag. I can read. This reads all the 16 blocks. You can read the system area. You got the system area, and you can also write. So you have to be careful when you write to system area. So likewise, this software is it's pretty basic. You can just do a simple read or a write operation, but in order to do a proper write, you have to understand the structure of the various blocks. Now I'm going to write the second, cancel it. I'm going to write to page number, to block number 1 to block number 5. Sorry, it's yeah, you have to be careful here. So in fact, I just wrote to block number 1, but block number 1 is not the user area. It is the OTP. It's a counter. So look at that, block number 0, it is a resettable OTP bits, and this you cannot undo this, you cannot undo the write operations here. So once the bit is set to 0, you cannot change it back to 1 unless we do some other extra command I'm going to show in later videos. So the safest place to write is from block address 7 onwards. So keep in mind, please do not write a random data in block number 0 to block number 6. I did that by mistake. So block number 7 to block 15 is user area. So go to block number 7 to block number 9. I'm going to write, just write 44, 45, 7. Or you can also fill the entire block with maybe something here. We'll try that later. It says write single block, but not sure what it did. Read. Okay, in fact, we have written for all the 3 blocks. Now I'm going to reset that with zeros. Alright. Read, or read from 0 to F. Yeah, you can see here we have written for block number 7 to 9. So I think that's all about, it's a very, if you understand this commands and the state diagrams here, this is a pretty easy tag. Next, I'm going to show you how to use more than one tags. So I'm going to place 3 SRI512 tags here, and the easiest way to use or understand the multiple tags is to use this the single operation, the anti-collision. Hit that. So many things have happened here, but only 2 tags have been recognized, as you can see here. So the anti-collision step has identified a chip with the one tag with chip ID 81, other one is B6. So however, I have got 3 here. It's all because of the way you place the tags. So I'm going to do this anti-collision again. Now nothing came. It's because, okay, now probably the best thing is I'm going to distribute them. Oh yeah, so we got 3 tags here with the different chip IDs. So we are I'm going to show you how to write. We're just going to follow the very first diagram I showed you. So we're going to select this one at a time. So I'm going to first write to this FF. So you just can't identify which tag is FF and which is 68. Now we know this, there is a tag with the chip ID FF. I'm going to enter FF and say select. So it's selected probably. I'm going to read. If the read is successful, then it's fine. I'm going to write something to block number 7 to 15. Right. So I'm going to fill this with the zeros. Right. And read. Now we are able to now read and write for this tag. Now I'm going to send this completion command to this tag. Now this tag will, if you look at this block diagram here, so the tag is in selected state. When we send the completion command, it will go to the deactivated state, and the only way to reuse this tag is to take it out of the field and put it back. Now I'm going to hit this completion. Now if you try to read, so you will get error message because that tag is no more in the selected state. Now I'm going to try this time with 92. I know the tag with chip ID 92, it's still in the field. I'm going to select that and let's read. We're reading still the this was the tag we used before. Now I'm going to write fill this with 11 and read. Now we have done it. So I'm going to send this tag to the deactivated state, hit this completion. We have got only one tag left, that's 68. Type 68 and say select. The tag is not very sure. Let's try. Okay, now, oh sorry, it's not 68, it's 6B. Select. Yeah, you just have to make a notice this response here. Now you should get a positive response when you select command. If you get something like that, there's something went wrong. Now if you look at the documentation, the select command will return you the chip ID. Now if you look at the chip ID is 6B, the 6B is also present here. So this is the response. Now click on read. Now everything is right, so I'm going to write with the value 22. And read. So we just written that. Now I'm going to put this on completion. Now even though we have got 3 tags in the reader field, none of these are usable because they are all in the deactivated state. Now just give a try and try to do this anti-collision again. Now yeah, it looks like the anti-collision probably I think the anti-collision command might turn off the antenna and then start all over again. So this time we have recognized the same 3 tags but with a different chip IDs. Now we just don't know which is selected. If you just hit this get UID, we got some UID, but we just don't know which one is that. Okay, the next thing in the document you have to understand is the way the anti-collision is done using the SRI tags. Now there is a nice explanation in section 7, and there's a good example as well. So I'm going to show you using this CR95HF tag what this anti-collision does. It basically uses 3 commands: initiate, pcord 16 and slot marker. So to put in simple words, anti-collision is a way of finding the tags that are near the reader writer. And we know that every reader, as soon as they enter the reader field or as soon as they receive the initiate command, they automatically produce a random number, 8-bit random number. Out of the 8 bits, the last 4 bits are called as a slot number. Now it is this slot number that is used to find the various all the RFID or all the NFC tags near the field. Now first we are going to see what's happening when you click this anti-collision. Now I'm going to clear this. Just I'm going to blindly hit this button, anti-collision. I also got the same 3 NFC tags placed here, and if I hit, now you can see that only 2 tags are recognized. So you can try just probably I'm going to try this again. This time also probably it depends on the way these tags are placed. I'm going to try again. So clear. Okay, in fact nothing came this time. Okay, so somehow I just cannot get all the 3, but it's alright. Let's go through that and see what's happening between the board and the software. Now the first command, send a reset inventory. So this is basically telling all the tags come from whatever state they are to the inventory state. Now you see here this one, okay, so inventory state. So it also means if the tag is already in selected state, you're just bringing all to inventory state. So before this anti-collision can start, all the tags must be in the inventory state. So the first command, reset inventory, brings any tag in selected to the inventory. So after that, the initiate command will take care of any tags that have just entered the field. They will be moved to inventory using this transition. Now after that, the pcore16 command is sent, and the documentation says as soon as the pcore16 is sent, all the tags will generate a random number and they are ready. And after that, there's something soon after that, there is a select command. It is because if you look at this chip ID A0, the last 4 bits is 0, and the documentation says if the slot marker is 0, the chip, that particular chip will respond with the chip ID for the pcall command. So as soon as the reader writer receives the chip ID, the reader writer will first send the select command, so that once the tag is in the select state, it will never respond to the the anti-collision commands like a pcall or a slot marker. Now this is a special case where the slot number is 0 and got selected. The next is select 0. After that, so we identified the first tag. We identified a tag in the slot 0. Then we are going to see is there anything in slot 1. So this is the slot marker 1 command is going to do. It just if any tag that's in slot 1 after receiving this command will respond with this chip ID. So here, we have got nothing in slot 1, so you got a no response message, no response as output here. The next slot marker 2, there is nothing in no chip ID with the slot marker 2, so we got no response. Then sending slot marker 3, got no response, like that 4, no response. So like that, in slot marker 5, the reader got a response. Now if you look at the corresponding chip ID, the last 4 bit is 5. So because there was a response for this command, the reader immediately sends the select D5. And after that, this continues for all the remaining slot from 0 to 15. So you can see here, so finally it has reached the slot marker 15. So at the end of slot marker 15, the reader has identified 2 tags here. You can try this again, and I'm hoping to get all the 3 tags this time. Okay, all right, just it's not lucky this time as well. Okay, so we are able to get all the 3 tags this time. Now how about trying these commands by ourselves manually? So I'm going to show you that. Now I do not want to take these tags away. Instead of that, I'm going to disconnect my CR95H board from my USB port. I've connected back. Okay, now we're going to do exactly the same commands. I'm going to first send initiate command. After that, I'm going to send pcore16. Now after that, I'm going to send the slot starting from 1. So we got not, in fact, this is not the right response. There's something wrong here. Okay, so send initiate. Now looks like there is a kind of a collision here. That's fine. Now I'm going to send the pcore16 command, and we got a response, and I think this is we identified the chip with the ID E0. I'm going to use that E0 and select that chip. So we just look at that, we just identified the very first chip in slot 0. So I'm going to continue with the slot 1, change this slot marker 1 and click this slot marker 1. There's no response. Set this to, this is a bit of a lengthy process here. You have to start, and you got a response for slot marker 2, and we know the ID is 82. I'm going to select this 82. You got selected, and continue with the next slot 3, no response, and slot 4. We are using the binary numbering here. Slot 4, no response. Slot 5, okay, and slot 6, sorry, I did try slot 5, so slot 6, slot 7. Yeah, we found one in slot 7 as well with the ID 77. I'm going to select 77. Now we have already identified 3 NFC tags here, and so I don't have to continue from slot 7 onwards, sorry, slot 8 onwards. So however, when you do this programmatically, you will end up going from slot 1 to slot 15. So I've selected this. I'm going to do a read operation here. I got something here, and I'm going to select this time, if I remember that it was E0. So I'm going to select 82 and do some reading. I'm going to select an E0, select that, do some reading. Now if you have noticed here, I did not clicked on completion. So instead I've just selecting a different chip ID. If you look at the documentation, so while the chip is in selected state, if you select a chip that is a different chip ID, automatically the chip will be taken to the deselected state, which is different from the completion or deactivated state. Now when the tag is in deselect state, you can always select it and start operating with the tag again. Now in all this time we have seen this completion path and went to the deactivated path. So we are going to try this time. I'm going to again go back to tag 82. I'm going to select 82 and say read. Look at that, we are able to read. So like that, assume that you are doing a project where you copy from one tag to another tag, or transferring a huge data, not for SRI512, maybe SRI4K. You can use this concept of reading few blocks from chip 1 and transferring that to chip 2, again going back to chip 1, read remaining 4 more blocks, transfer to chip 2, likewise. So you don't have to deactivate. So here we are just going back and forth between the tags. So that is all in this video. In the next video I'm going to show you how to use these tags but using the learning tool. We're going to understand how to change the system areas, how to work with OTPs, and how to work with the counter, and how to understand the reload operations. So everything will be discussed in the next video. Thank you.